Today, we'll take a look at how we can automate a revenue forecasting data pipeline using Trel. So here's the problem statement. We have a table sales in a MySQL database. This table is having frequent inserts and updates, and we need to generate some daily sales statistics from this data, and we would like some forecasts to go with that. And we want all of this shown in a dashboard. So when we use Trel rather than Airflow or DBT for this, how is it different? So the main difference is we use something called catalog-based dependency rather than DAX. So in catalog-based dependency, sensors do not trigger jobs. Instead, sensors add paths to the data that they found or that they loaded into the catalog with certain classifications. Furthermore, jobs do not trigger jobs. Jobs are triggered by uh, the presence of data in the catalog with certain specific combinations of classifications. So this is a pretty different approach from DAGs, and we'll see how this works a little more when we look at the solution design. Next, we also follow the Trell design guidelines, so which suggests that certain properties such as immutable data sets, idempotent jobs, and achieving execution time invariance in your data pipeline is highly desirable, and it recommends that we follow certain steps to achieve those. In this case, we're not really going through the design process. We're just going to look at the final design itself. This is something we follow. Also, when using Trell, data organization and automation is done through configuration only. The job that you actually write only has the core transformation code, the business logic, and it doesn't have any data organization or automation code whatsoever. We'll take a look at, I'll explain how what the job actually looks like, and we'll also take a look at the code briefly. Now, the final result of Trell is a data lakehouse rather than a data pipeline. In my opinion, a data pipeline is a simple approach where let's say if you were to just take the sales table and do some um, transformation on the spot and directly load it into, let's say, something like Vertica, and you just generate the plot using Vertica, and tick a button, you get a trend line, and that's it. That's your final output. I mean, it would practically be the same as what we're doing right now, but that qualifies as a data pipeline. What we are going to do is what we're going to be building is more of a data warehouse. So let's take a look at what it looks like. So we're going to have a couple of sensors that are reading from this MySQL. They're both reading the sales table, but the sales diff sensor is trying to get the data just for each day. The period is corresponding to each day, but the sales table is trying to load the data up to certain days, up to the date that we are trying to load. Um, and the like I said, each sensor catalogs the path that they loaded into the catalog with certain classification. So there are two different dimensions of this classification that we want to focus on. One is, of course, is simply the name of the data set. So here it is going to be sales diff. And second is the timestamp for this data set. So the timestamp for the data set corresponds to the period of the data. We're going to see that in the next slide, more about it. And then we have the merge sales diff. So this job is goal is to merge the new daily sales diff into the sales table to make a new sales table which has those updates. Uh, then we have this forecast revenue job, which is written in PySpark, which reads a sales table and generates the sales stats. And then we have a small job which will uh, load this, not load, but more like register this data in S3 as an Athena table, and we have our Redash dashboard, which is going to point to the Athena table, and that's already done. So this is much more of a data, lake house or data warehouse with data lake as well, um, because at this point you have a lot of checkpoints for the data. Every data, all the intermediate data sets is stored in a lake technology and cataloged, and you can pick up any of them and start writing more jobs, allowing you to branch off and grow your data pipeline or make it more complicated as much as you need. Versus, if you wrote the simple one, it would be hard to do anything more than trend, because Vertica probably doesn't support more than that. Okay, so let's take a look at the sensor. So there is this idea of the clock-based sensor. This is a class, and this class is suitable when the data availability depends on the clock. So one example is a Twitter API, right? You're getting tweets from Twitter. If you want to get tweets for a specific hour, then you can pretty much know that that hour is ready when that hour finishes, and maybe a little bit of time into the next hour, let's say a minute or two. um, the same logic applies for an application data table. If you have a data table and you decide, you're running it daily, you want to make a daily pull, and in each pull you want the data for a day to be complete, right? Even if you're just pulling that day, or if you're pulling all the days until and including that day, that will be ready like a few seconds, and maybe 1 minute into the next day. um, in such scenarios, the clock based sensor is best because it has pre-built functionality for specifically that kind of logic. So you use it by providing some parameters. The first one is a cron expression, which splits up the time into various periods. So you get hourly cron, you get hourly periods. Um, and then the sensor will call your loading function to say that, hey, load this data for this period into whatever you want to do with it. Now, in this case, our sensors is actually called an ODBC sensor, which inherits from clock-based sensor. And ODBC sensor reads data from an ODBC data source and transfers it to S3 or BigQuery. In this case, we are using S3. Typically, it just does a select star from table, but it can take custom queries, which is probably what you want to do, and it will be parameterized with a period start and period end based on the clock-based sensor logic. Um, and when you will also be given the path to load it into, and that path will be registered in the catalog with the timestamp. Like I said, there are two dimensions that we want to worry about when we register into the catalog. One is the name, and second is the time, and the time will be set to the period start of the period. So now that we have the time and the date, and the time and the which is the date and the name of the data set in the catalog, and we have two different types. We have sales diff and sales. We can do a merge sales diff. So it has to take yesterday's sales diff. It has to take day before yesterday's sales and produce yesterday's sales. So the formula is right there. And this job allows us to maintain a complete sales table in data warehouse while loading only the daily diffs. This is implemented using PySpark. And in this code, we actually have very little um, code. I mean, practically no code related to data organization or cluster allocation or anything of the sort. So let's take a quick look at what it looks like. Here we are. So as you can see in this PySpark code, we essentially provided all the parameters that we want, the two inputs and the outputs, and we are just doing our Spark stuff, and there is nothing else. No cluster allocation or a data organization. So, and this is just the way it works in Trel. The next, let's take a look at the forecast revenue. So in this job, we have to generate the sales stats dataset class from the sales dataset class. And our sales stats consists of two columns: the sale date and the total sales. And there's some forecasting also being done in this. So the sale date will extend beyond the dates that which we have data for in sales. This is also implemented using PySpark, and we are doing forecasting using NumPy, and we just have a simple trend model. So let's take a look at what has been set up so far. So we have some repositories registered with Trel, S3 US East 2 and Athena. These can be done with one line each. We have some credentials registered with Trel, and these are also done with a line each. We have a Redash instance already set up with a dashboard already built, and it is pointing the sales stats table. um, we also have our sales table ready in a database called test, and as you can see, we also wrote the transformation logic for merge sales as well as the forecast revenue. Okay, so with this, let's see how we can get this pipeline going and the dashboard updating. Let's start the clock. Okay, we can start the clock by using date. It's an hour and 6 minutes past midnight UTC. Okay, so here I have prepared some sample registration files that I can use for sensors and the jobs. Let's start by using this ODBC registration file to make the sales sensor registration file. Okay, let's start by filling this in. This is sales. So the code for it is already written. It's a common code. Nothing that we need to change. Um, is specified over here. This is sales. Um, it's all okay. This is S3 US East 2. We're not going to worry about schema until we get to sales stats. This is okay. We're not going to provide credentials in the registration file. Instead, we're going to use this. We already entered um, using this mechanism. Uh, we give it our credentials a name, a key, ODBC.trel test. So we're going to specify that. This is test, and this is sales. Okay. Uh, so one thing what we want to do is that we only want the sensor to load this table one time, because the rest, otherwise we just wanted to use the sales diff. So to make sure that it's only happening one time and it is happening for a somewhat recent time, we're going to say that this has to wait 3 days. So 86400 times 3, which works out to uh, 259 259 uh, 200. Okay, and we're going to put the endpoint as well. We're going to say don't load anything older than something, and this we want to be 86400 times 5, and that works out to 43200. Okay. Now we want to load the data from sales as for that period. And the definition of the data for some period is all the data that is including that period and before, as if we just pull the data just after the period. Unfortunately, this table is not set up to be able to pull something like that. Like I can't go back from 3 days. I can't come up with the date 3 days ago and say that I want the table as of that date. It's just not going to happen because the table has changed since then. So the best thing I can do is I can avoid any rows that were created after the time frame that I'm interested in. So see, that is this one right there. So create a timestamp, an instance timestamp plus 86400. Create a timestamp should be less than that. So okay, so good enough. Okay, so shall sensor register, shall sensor sales. Great. So I've created my sensor. Now I have to enable it. So update sales enable. Okay. Now it's started running the background. Let's see if some data sets have been generated. Voila. It already looked at the database, pulled one date for me, some data based on some date, and already loaded it to S3, registered in the catalog, all done. All right, great. We're done with this one. It's time for the next one. Shell sensor sales becomes sensor sales diff. code is still the same. Generate sales diff. Still not worrying about the schema. This is fine. This is all the same. So delay, now we don't really care so much about the delay. It's a 60 seconds should be enough. We can pull the data after 60 seconds in case some transaction is still uncommitted. The code for this. So here we can do a little better because this is a diff. We can now focus on modified timestamp, but unfortunately we can still only limit one side of it. So anything that is modified after the start of the period is what we can take. We can't put an end period because some of them may be modified again, and we don't want to lose those rows. So we don't want to miss any rows in the diff that belongs there. So we're gonna just limit one side of it. Okay, and that's what it is. This one. So if you keep it same as this, let's keep it same as this and go with that. We'll see what happens. I'll send this. Enable. Okay, running sales diff. Okay, so it again figured out which all ones it had to add, which all ones are missing in the catalog, and filled all of it. So because we said 5 days, it's filled in 510 through 513, and but we only have 510 for sales. Great. And now it's time to go to the next job, which is the for no the next job that we want to look at is merge sales diff. Okay, so we're going to start from this one right here. So cp that trel regis merge sales diff.yaml. Okay, so this one is called merge sales diff, and we don't need this here, so we're going to remove it. But the cluster we're going to run it already has some DS stuff as well. It doesn't really matter. Okay, our code is going to be complete pipelines demo revenue. And merge sales. Okay. So because we don't want to wait 5 minutes for each run to spin up, we're not going to, we're going to use an existing cluster, a standing cluster for this. Here we have it. Okay, so here we want this job to read sales as well as sales diff. So we're going to have to specify both of them here. And for output, it's going to say generate sales because we want to merge sales diff into sales and then create a new sales. So name, we're going to give it a name because there's going to be conflict due to the input and output having the same name on the command line. So it helps, this helps it disambiguate. This is not a single instance. This is a periodic scheduler. There are three different types of schedulers. I'm not going to get into the details of this, but kind of looks that's what it looks like it does. We say it self depends on sales, means that its goal. This is a job that updates something. So this is the schedule that for jobs that update something. So it updates sales using sales diff. That's pretty much what it means. Okay, so um, let's run that. Trel register that. Okay. So we're going to run one manually. So we're going to run something it can't have. So I'm going to say run 2022-05-10. It can't do this because it doesn't have sales 459 because that's the formula. So let's just check that. So it refuses. It says, I cannot do this because no valid and complete input data sets exist. But it can do 511 is going to use 511 for sales diff and 510 for sales to generate 511 for sales. So, okay. So we're going to run that. Let's quickly take a look at our clusters and see how it is. There you go. So the task is added as a step into the cluster and it is running. Okay, so let's get to the next one. Uh, all right. Uh, cool. So we have forecast revenue. This time we need it, but again, it doesn't matter because the cluster is already running. This is going to be um, complete demo revenue forecast revenue. We still have a cluster name to provide. This time it's going to be this one. Mm, the repository map is a little simpler because we're just processing sales and nothing else. Dataset is just going to be sales stats. All this is true. Um, it depends on sales alone. Okay. I'll register. Great. Now, before we run this, sales stats has a complication that we want sales stats to have a schema because we need that schema to load it into Athena. The simplest way to load into Athena is to have for it to have a schema associated with it. And to add a schema, we actually have to add the dataset class first. Usually, if the dataset class doesn't exist, it gets automatically added. But here we need to add the dataset class manually so that we can add a schema for it before the datasets even exist. Copied that wrong. Okay, so this is what the schema looks like. There is a dictionary. There's for one key is columns, and there is a list of dictionaries specifying the column, and it's also there was a format. This is not really something that Trel controls, but it has to be whatever is compatible with the the code that is going to read the schema and try to use it. So that's pretty much all that matters. You can define whichever the schema whichever way you like. I think over time we're going to be coming up with some standards, but for now this is pretty much defined by the code which loads it into Athena. Okay, so we are also going to set this as the default. So trel schema update sales stats on set default. Okay. So meanwhile, let's just jump back to our this cluster and make sure it ran through. So it ran through. So let's see what that looks like. Now you have 511 of sales from this task that we ran. So if we ask for a report, it's going to tell us this is the job, this is the code that it ran, branch, all everything. It used this and this data sets and it produced this data set. Note how the paths are all different, as well as the instance timestamp changes. Sales was input 510, output 511. Okay, so now we are safe enough that we can enable scheduling on this. So say job scheduler. Yes. And trigger schedule, because the jobs that we want to run, the tasks that we want to run are sort of a backfill. Okay, so this is trigger scheduler is how it when it goes and check for a backfill. Okay, next, we registered the forecast revenue, I believe here. So then let's run a forecast revenue as well. Execute. We have two sales. We're going to use the 511 for it. Forecast revenue 2022 511. Let's wait for. Let's not wait for it. It's okay. Let's run. Okay, let's see if the uh, yes, the task got created and the step got added. Excellent. So, and let's jump back and make sure that this one is doing fine. Let's just look around a little bit. Trel tasks. So here we can see that merge sales for 512 is running, and it's going to generate sales for 512. And when it generates sales for 512, it's going to realize, Trello is going to realize that you can now run merge sales 513, because that requires 512 sales and 513 sales diff. 513 sales diff we already have. Uh, we have 513 sales diff, so it's going to be able to run one more merge sales diff all by itself. Okay, so it did that, and it's going to be picking up the next one pretty quick. Right. So it picked up the next one. Waiting for, okay. While forecast revenue runs, we can get started on the um, Athena push job. So Trel Regis appende. So Trel Regis. This job is called S3 to Athena. Athena sales stats. Demo. Okay. It's a Python code that we're running. This one is new. This is okay. Okay. Um, we just have one, which is sales stats, and this reads from S3 US East 2. Okay. We just want a single instance scheduler. It depends on sales stats. Don't need that. This is master. Okay, that one is done. Just by convention, let me just put this up here. Okay, we don't need this. Now there is something special. Now, instead of specifying that we want it to be a different name, we don't want it to be a different name. It has to be the same dataset class. It's just a linking. We're just moving to Athena. The since the data doesn't change, we don't really want much of the dimensions to change. The only thing we really want to change is the repository. So we specify the repository here for starters. So which one is Athena E2. The second thing to be able to specify is that where is this supposed to go? So alt URI, because we don't want the location to be suggested by Trel. This is sort of reverse ETL, and it's going to be looked up. I mean, the dashboard, our Redash dashboard is going to look for a specific location. So we have to specify that location here, so that that is where the data gets generated. Okay. Third thing we want to specify is that this is actually a link uh, to the input, because this is required because Athena doesn't actually store the data. and is depending on this S3 data set to actually provide the data that it needs. So for safety, we want to say that this is a link, so that certain Trel systems will protect, will understand there is a relationship and make sure that the S3 data doesn't get deleted before the Athena data set. That's all looking good. I can quickly check our cluster and make sure everything is going okay. Merge stats has run through. Merge sales diff has run through. Forecast revenue has run through 511 as well. Great. So Trel register. Okay. Trel data sets, sales stats. Okay, we have one sales stats to push, so let's push that. Trel execute S3 to Athena sales stats. Yes, 22 511. We'll wait for this one because it's going to finish fast and it doesn't require any cluster. Great, successful. And we can see that the output that is generated is sales stats 511, and it has the path that we told it to take, the sales stats. Okay, so now we can go to our dashboard here, and we can, this is from a previous time, we can refresh this, and it got a different uh, dashboard, sorry, different chart. So this is all just mock data, but and this is the forecasting trend line that it computed based on this data. Let's get back to our timer and see how well we are doing. Okay, so that's about 22 minutes to fully automate this pipeline and verify that everything is. Oh, we may have missed a few steps. Um, let's see, enable scheduler. So we should do this for um, forecast revenue, as well as trigger this as well. And we should do the same for okay. Then if you look, it's trying to run two different forecast revenues. So forecast as of 510, 512, and 513. That I only set two workers, so there's only two workers going on here. As soon as the forecast revenue comes out, it's going to start, this one is going to start pushing it. This one is not going to get pushed because of the logic within it that prevents older ones from getting pushed. But this one and then this one is going to get pushed. All right, let's check them again. Okay, added a few more minutes, but great. Yep, that's the end of the demo. Just a quick announcement. As of May 2022, Trel is in beta, closed beta. So if you want to try this out, just contact us. And during the closed beta phase, we have close consultation, 1:1 consultations with the developer. We have architectural advice, free architectural advice on how to use it to solve your use case, as well as very short turnaround time for any requirements that you have that is not currently being met by Trel. So we'll just focus on finishing a use case first, which we run for all our closed beta customers. So just contact us, and we will we'll get you going. So thank you for listening, and please like and subscribe. Take care.